All right. Okay. Again, welcome for joining this live coding session. Let's start coding. So a bit about the background of this meeting. On the last community meeting for YJS, Francois, who didn't even join this meeting now, he proposed that we maybe do a live coding session where we build a collaborative drawing app, because he had a lot of questions of how one would do that. There are some performance improvements you can do to make this actually viable. And I think drawing applications and any kind of canvas application, that's a very good use case for YJS. And I want to show you how you can make that performant and maybe give you some hints of, performance tricks and all that other stuff. Feel free to ask questions. I'm going to start sharing my screen. All right. All right. I hope you can see my screen now. I increased the font quite a lot on my computer, and everything looks way too big now. All right. We're going to
looks great for us.
That's good. So. We're going to use Replit because I want you to try out the application while we are building it, and maybe later I can even invite some of you if you have questions, if you want to do some additional features. Let's start a Replit. We should have named it better. Let's give it a better name. All right, let's see, awesome drawing app, live coded. All right, who knows if it will work in the end, but we will make it work eventually. All right, creating this application. All right, our first bug doesn't work anymore. Another cool. Now that does work. It doesn't like parentheses, apparently. And we want a drawing application that is fairly similar to, so we can use any kind of framework for doing this, but I thought maybe we use something simple, and then later you can use a more extensive framework. I know on Twitter, people were suggesting other frameworks, but perfect-freehand is really cool. It does just one job and it does it really well. Basically, what it can do is, we can try out the demo, I think. Well, maybe first explain what it does. The idea is that you want your lines that you draw on your screen to look like handwriting. So you want different thicknesses while you're writing. When you have a cursor, you only have like button on, button off. But when you have a canvas stylus, like a pen or something that you can use on a computer or on your tablet, on your phone, you have different pressure points that you can use, and perfect-freehand will render that really nicely. One example is here. You see it looks pretty neatly written, although this was written with a computer. I can write my name. I mean, it looks quite nice, right? It has like a different. It looks fairly natural for what it can do, and you can adjust it quite a bit to your needs. But just know the real use case for this is that you have a stylus on your computer. All right. By the way, this was created by Steve Roos. He did some awesome applications regarding drawing applications, and I really want him to use YJS, which is another reason why I wanted to do this demo. Okay, so what does this do? Imagine while you're drawing, you're creating coordinates on your screen, right? You're moving your cursor, and when your mouse cursor is pressed, you are creating coordinates that you want to store somehow, and then you transform this to a SVG object, or maybe on a canvas you draw somehow with different thicknesses. And this is what perfect-freehand basically does. It creates a stroke and returns an object that is a polygon that you can then draw on your canvas or on your SVG object. Here's a small example. Basically, this is what you can do. Wait, let's take this example. You listen to an event pointed down, and then you add these points that you press while the pointer is down to an array of pointers. And eventually you get the stroke using the coordinates that you stored. And this is basically a polygon. And then you transform this polygon to an SVG canvas. This is what we are going to do, but you can also transform this to something you can draw on a canvas object. We get this object and then add it to an SVG object, basically. So we are going to draw it. All right, maybe we start with this one. Let's copy paste some code. First of all, we are going to use, right, this is the index HTML. I only used this one, this wraplet once, but I think it's fairly easy to use. So we are going to create an SVG object. All right, cool. And later we are going to add a polygon to this one, which is a path. All right, we have a script file. Oh, nothing is included yet. And first we need to somehow install perfect freehand, but because this is like a web, let's call it a web IDE or something, you can't really install NPM packages or something. So we are going to use a CDN. We import, this is an ESM module that we're going to write from esm.sh.
Evan, you should be able to use package manager. Maybe you started from a template that's just like a HTML page template. There's like node templates. Like you might be able.
Yeah, but then it's a node. Then it's a node package, and we can't render canvases on node applications, right?
No, it's a node plus front end. Oh, I see your point. Maybe keep going.
Yeah, but I kind of researched it and I didn't find a way. There are just some pre-installed packages that you can use here. Packages. Yeah. We can search for YJS or perfect freehand.
Yeah.
But it's not here. Nope. There are just like popular ones, like super popular ones, like React and all this stuff that people want to use and something like this. And this is why we are going to use a CDN. But I mean, CDNs are awesome because you can do this. Perfect freehand, and then you just add a version number. What is the latest version? Let's use tags. 109. Let's use the latest one version. And we are going to use the get path method that we saw earlier. And this should compile. We can check this using maybe just to confirm that this is a function. It's we need to make it an ESM module. We can do that using this, and how do you do this? I did this once.
Type equals module, I think.
Yeah, exactly. Type equals module. Okay, and all right. It doesn't have an export named getPath, but it was something else, right?
I think you did the wrong version there. You had to just be one and not.
Oh, that's fine. You can specify a specific version like 101 or 109, which was the latest version. But if you just specify one, it takes the latest one release, which is what we want, and then installs it. Basically, it always points to the latest version, which is what we want. But we, for example, don't want to use version 2, which is what we would do if we do. If we're here, we can also omit this. This is completely fine. But then we always use the latest version. And this is not what we want because eventually Steve is going to upgrade his package, right? And then our application doesn't work anymore. So we're going to point it to 1. And I just saw that it uses get stroke is the name. It's not get path. Makes sense. All right. Run this. Yay, we lock a function. Cool. First success. We locked the function. Welcome to this tutorial. We're also going to maybe install YJS as Y from, because we need it later, right? I'm going to copy paste this, and this is called, and we are on version 13. That I know out of my head. Okay, and during this tutorial, I'm just going to, because I like to do this, because I will forget it later, I add some properties on the window object so we can use it later while we are debugging. We often need the Y object, and maybe for now we also need get stroke, because otherwise there's no way to access these functions. This is just something I like to do. Remove this later. This is just debugging. Okay, we can try this maybe. We create a stroke like this. I like to use this version because it is this will compress nicely when we use it later in YJS. So these are the same version, the same representations. Basically, this one just uses arrays. Here it uses X, Y properties and a pressure, and here we don't have property names, which is what we want. So let's copy this. We can now lock the stroke maybe. Yeah. Then you see what a stroke looks like. Let's run it. All right. You can see this is a polygon. Basically, these are a bunch of XY coordinates. This is a start coordinate, and then we basically draw something like a circle or something. You know, we draw a shape, and this is the shape that we draw. And in the end, we connect these coordinates together again. This is what a stroke does, basically. And by the way, these are not absolute positions. These are always coordination changes. So first we start at this position, and then we move 5 pixels to the right and 1 pixel up. And, you know, this is how we draw this. I think I might talk nonsense because I usually don't do stuff like this, but yeah, then there's this nice function which transforms a stroke to a path that we can then use in SVG. All right, I will maybe make a quick the path in SVG. In the end, oh my God, it's in German. MDN English. That's better. Okay, this is what we want later. A path is basically, we can make it a polygon. This really depends on the properties here. But this, for example, this draws a shape. This starts, M always stands for start at position 1030, X, Y coordinate. And then we draw an angle. In this case, I don't understand all of this completely, but you can, this is so complex. Why can't we have a less complex example?
I mean, well, it's basically it's usually the commands, right? It's like move to line 2,
exactly.
Quadratic. That's probably quadratic, the Q.
Yeah, exactly. Yeah. And our example is going to use a Bezier curve, which is like a rounded curve. So we could like draw straight lines, but we don't want that. We draw like smooth lines. And for this, we are going to use a Bezier curve, which is basically something that it's here. What Steve already provides as an example. Here we start at position this one, and then we draw a Bezier curve, which you basically define with the Q here. This is some wizardry. You don't need to understand it. Just know it transforms a stroke to an SVG path. We could go more into detail, but this is more about how you build a YJS application. So we transform this to a path. So let's name this path. Oh, first, we don't need this one anymore. We store this function, and because we write idiomatic code, I like to do it like this. Other people like to do it differently. That's fine. But we don't need parentheses like this. Cool. Now we have this cool function that does that. Basically, we can now transform the stroke to a path, which we do like this: get SVG from stroke. Very cool. And then we can lock this path again. Cool. Let's try it. And this now looks a bit different, right? It's a string. It has start positions, and then, you know, it's a command, as Francois just said. Basically, go to this position with this angle, and, you know, it's cool SVG magic that we don't need to understand explicitly. But basically, we can now create, let's call it SVG path object. We create an element. It was called path, right? Yeah, path. And SVG path has an attribute, which was D, I think. Yep, D. And we set it to path. So basically, we could do like this, maybe. We just store it on this SVG path, and then we add it to the global SVG object. And maybe let's define this SVG object once, because we defined it here in the index.html, right? We can just search for it. And we know it's always there, so it's always defined. And we also want to access it maybe at some point. So I'm going to log it here. And then we can add it to the SVG object. Add pen child. Cool. SVG path. I'm sure it won't render because there was something that I missed. I did this in this demo before, but I always need to look it up. It is, how do we create an SVG path object? Because we can't just do create object or something. No. Okay, I'm going to look it up in some example code that I wrote. Yeah, this is it. Here we go. Not this one, this one. I need to put it here. Basically, when you create an SVG object, like a path or a circle or something, you always need to append a namespace, which is, you know, not something that we are used to as JavaScript developers who are working schemaless and stuff. But, you know, a long time ago, we had schemas on HTML, and this is what you need to do to create an element in a different schema namespace. Basically, if you want to create SVG object, you need to append this. All right. This is SVG path. Cool. Path is not defined. Path.
The console statement. Yeah.
Yeah, that makes sense. Okay. Oh, you see something very small up there in the corner. All right, it does work basically. We are finished. No, we're not. So the reason why it's so small is that I'm not on a large screen anymore. So it should be fine to do like something like this. All right. So this basically is in pixels, right? And So how many more points do I need to add to make this work?
I think you need to give the SVG a size, don't you?
Right, right. Good point. Good point. Good, I have you. Yeah, SVG is basically fairly small now, right? We can maybe look it up. Cool. Yes, SVG is like this, and the body has a margin. And how do we make something full screen again? It's first of all, let's remove the margin, body, and what is the other thing that we have? Body and HTML. Margin 0. What else is there? Heading maybe. So something else, and then we make the SVG full screen. Position is fixed. Top left with 100% height. Okay. Still doesn't work, but it's now a bit more to the top left, so that's good. Let's reload this. It's full screen. It's just really small. Why is that? All right, let's go over this. Maybe different pressure points or something. So we start at 0 and then go to this position. Maybe we can make it like 3000, 3000. So it should go bottom right if we do this. But it doesn't go bottom right. Why is that? Why is that? It's very small. It has a lot of coordinates. Huh.
I mean, I'm not sure. The SVG tag is bigger than that already, is it? Because what I was talking about, that the SVG is like an image. It needs width and height. But I mean, you scaled a tiny image to the full width, but it's still a tiny image.
Is that so? Is that the problem?
I'm not sure. I'm not sure. I think you've debugged it and it was like 300 pixel wide, but I'm not sure.
Yeah,
I think you need to add.
It is way too small. So this shouldn't be 11 pixel. This should be full screen. And basically, when you don't define a view size or viewport, I think, then it should use default pixels. But what I think is happening.
View box. It's called view box, but yeah.
Yeah, view box. Exactly.
No idea.
Yeah. No.
But I think Steve had an example of the SVG tag.
Yeah, I know, but I tried to do it from scratch, but you know, maybe we shouldn't. I have some code that I wrote earlier just to confirm that, you know, everything works. I had this method. Here we go. Okay. Nothing changed, right? Oh, I thought I modified it. Okay, this should work. Then we add it to this one. I can check whether there are other style things. And I will use a different path. So I did one drawing example using, how do we call this? Maybe that like this. Yeah. I did one example where I drew something, and then I wanted to draw it using this again, but still it only renders a single point, which is really weird. Ha, I see it. Do you see the issue? I'm not sure how that happened. You see that? This is not a path. Okay, what are we doing here? We set an attribute like this. Let's log this. No, it does work. But why does it say path here? That's all fine. All right. I'm at least gonna copy paste some code now. Where do you think we should get the example from?
Just as a quick test, can you try setting like a fixed width and height on the SVG element?
I think we already have like top left width
No,
height.
the width right there. Try just like putting 500 pixel, 500 pixel.
Okay.
Nope.
SVG is sometimes slow on responding to stuff, so we should probably set it here instead. Let's do it like this. You can also do it like this. Now render. It doesn't render anything. Now it does. Okay. Renders the path.
Just as I'm not sure if that's confusing for you, but Steve has a code sandbox where perfect freehand is set up with an SVG. So basically all the perfect freehand stuff is done already, and we could use that to integrate YJS, or is that somehow not the right way?
I don't want to use React, but we can probably use that as well. So that was the reason why I just didn't start with his approach.
Ah, yeah, got it. Yeah.
Okay.
Sorry, then.
No, that's a completely fair argument. I'm just going to copy paste some of the code that I had. Just need to filter something out. Hey, I'm sorry for this. I have no idea what's going wrong, and I would have loved to debug this further, actually, but I think we should move faster.
This is real programming. It's
Yeah,
Googling and copy paste.
I mean, I'm not gonna, I'm not an awesome developer. I also Google all the time, right? So this is some SVGs that I set up before. And this is something that I actually copy pasted from Steve. Then I have this path that I was adding. I have this stroke, this path, okay. And basically I have this cool function here. I'm going to use this. So this was literally what I was using before. I'm just going to remove this. I created a helper function get path that takes a YJS argument and renders it somehow. But this is literally it. This is what we have already. So the problem must be with how we create the element. So I'm going to copy paste this code as well. All right. So this is working code. This should work. Create element NS path. Then we set an attribute like we do here with get path. And get path was my helper function. Ah. No, get path is.
Kevin,
Yeah.
Somebody from the chat suggested to use like viewbox and set it to some value. I tried that and that increases the size of the
Yeah,
header.
viewbox. Okay, I'm going to try that next. Okay, let me finish this here, and then I'm going to use viewbox. I think that's a good suggestion. I know that it works like this because even Steve's example is working like this, but we shouldn't get hold up this one. All right, this is the same code. Create a path like this, and I'm just going to make sure that our SVG is also created like this. Oh, this is the same code. It sucks. Okay.
So good to see someone else struggling.
No, it's completely normal, and I did minimal preparation for this, just so we can maybe find out some stuff together, because that would be much more fun. Yeah. Svg path has already been declared. Let's remove this. All right, it still doesn't work. Okay, in that case, yeah, please, that's, I don't have the chat open. I should probably leave it somewhere. How do I open it from here? Yeah, okay. Viewbox, all right, let's try this. Yeah, I will try this. All right, it's somewhere different, right? It's not here anymore. So what is happening to this? So it's a path. It's now full screen. It doesn't, okay. And it has a path like this. But we are using now a very different, we wanted to use our own path, right? Something like, I don't know if that makes a difference. It says 0.5 because that's in the example. We didn't even use this stroke that we had before. Okay, let's try this stroke. Chords. No, it's nowhere. It is very large, as you can see, but it's not found.
The viewbox is too small now because the first point is 300 and the viewbox is 100, 100.
The viewbox, that could
be
be
the viewbox of the SVG is 100, 100. And
you're right. It's somewhere
bigger.
Very different.
Just make it 1,000.
Okay, make it 1,000.
Then you should see it.
Yeah. Yes.
Yes. There it is.
Damn it. Okay. We did it. I have no idea.
Sprinkle some YJS on top of it
now. What went wrong here? Is it really the view box? Can we, or was it the coordinates? Let me try removing the view box, because view box makes everything so complicated. It was the coordinates. So apparently the coordinates, you couldn't draw these coordinates for some reason. Huh? Well, it doesn't matter. It does not work.
I think we can all agree that it's a bug in Steve's code.
Yeah, obviously, it's not my code. I only write correct code. Yeah, let's blame Steve for this, and also the authors of SVG to make everything so complicated. But no, seriously, SVG is awesome. It's really fun to work with. So basically, the next thing that we can now do is we can now, put this path in a YJS object, share it with other people, and then we can all go home or even further improve this. So very quickly, we want to create a YDoc. Yeah, at this point, I wanted to talk a bit about like designing your application, because a lot of frameworks that you might want to make collaborative, like any diagramming solution or something, has a custom data model. And then you need to represent that data model in YJS. And every time when one of them changes, you need to update the other. This is super complicated. This is how every editor binding for YJS works. Every time the editor, let's say prose mirror, changes, we need to find out the differences and apply the same changes to the YJS document. And every time YJS changes, you need to apply the differences to the prose mirror document. Very complicated, honestly. It is doable though. However, if you build an application from scratch, I recommend to build your application with YJS as the data model. You can build the abstraction around YJS if you want to. Like you can create your custom abstract drawing implementation, and then you can change the internals underneath. This makes a lot of sense for different projects. But for this project, we're going to use YJS data structures directly. And when we draw something, we don't draw the SVG directly anymore. We instead manipulate a YJS document while we are drawing. And then we have event listeners that fire every time the YJS document changes and draw the changes, differences to the screen. So we have a much simpler pattern. Every time we modify something, we only modify the YJS document. All right, we created a Y document, and now we create a data structure that can hold path objects. Basically, the idea is, so a path is like an array of, well, JSON objects. We don't care what's in there, but these are coordinates that we add while we are drawing. And then we need an object where we can put all the data objects that we draw. So we create how can we call this? Strokes, Y strokes, good name. And this is a Y array. So every kind of stroke that any user performs is created here and is added to this array of strokes. This will somehow look like this. It's an array of Y arrays. You will see later why. Of basically X, Y, Z. No, we don't have the pressure. Okay, this is somehow how it looks. Now we want to create a Y array, fill the Y array with these coordinates and add it to the Y strokes. Let's call it, I don't know, Y stroke. We're going to remove this later. New dot array, this, then we add coordinates. Maybe we can leave it here for now. All right, and this is something that is very confusing. If you want to add a single element to a Y array, you don't do this. You do it like this. You add an array of elements that you want to push. The same goes for when you insert something, Y stroke dot insert, for example. If you want to add a single element at this position, like you want to add X at the first position or something, you don't do this. You always wrap it in an array. The reason is that we want to improve the performance of inserting a lot of elements. And if you do insert for each element individually. This is very costly, especially in YJS. This is one of the most expensive operations that you can do. So try to bundle those changes and insert a lot of elements at once. And this is kind of the design pattern here. Luckily, coordinates is already in the form how we want to insert it. So we're just going to push chords to Y stroke. And then basically, you should, this is our first stroke. We push coordinates, and then we add it to the Y strokes object, right? This is a collection of strokes that we have. Bad naming decision here, bad naming, because they look very similar. Again, array of Y stroke. All right, what we can do now is maybe do a console log of, how do you call this? Y strokes. We transform this to a JSON object and log it. And then we should see the exact structure of this, how this will look like. All right, everything is still working, but nothing is logged. All right, I'm not as convinced anymore. Oh, I need to press run. I can't just reload a window. That's weird. Okay. Basically, we log Y strokes and transform this to a JSON object, and then we get the same coordinates that we have here. Basically, when we can do that, right, we can just do from now on, instead of accessing coordinates directly like we do here, we can maybe go here and do Y strokes for each. All right, now it's getting silly. Do I want to call this Y stroke again? I shouldn't have called it Y stroke. This is so inconsistent. Can I rename this? Yes. New stroke. It's much better. Wow, this is cool.
You renamed Y strokes too.
No, I want to use.
Strokes.
Did I rename Y strokes as well?
Yes.
New. Oh, this is stupid. Okay, this is. Okay, I just want to rename this occurrence. Y strokes, and then we add. Yeah, Y strokes. Thanks for noticing. This is why I have you guys. Y strokes to JSON, right? And now we can do Y strokes for each. We iterate through all the Y strokes. Now we have really a Y stroke. And then we render it like we do here, right? We have a Y stroke. Actually, let's just do it like this. Now we can copy paste this code, everything from here. Okay. Copy, paste. Okay. We get the Y stroke. We transform it to JSON. We don't need to transform it to JSON. We can just do to array. So we transform this stuff that we inserted into the Y array here. The coordinates we insert into the Y array. New stroke, push coordinates. And then we basically extract the same stroke information, put it into an object, and do everything as we did before, render it. So put a path on the path object and then add it to the SVG object. And this hopefully still works. Let's see. It still renders. That's really good, because what we can do now is we can create multiple paths. How can we do this? We can start listening to events on the SVG object, and then we can actually start drawing. Are there any questions about this? Why do we listen to Y strokes?
Oh yeah, so the for each, is it like a async iterator, or like that's the thing that will be fired every time when the object is updated, right?
Oh, this is just fired at the beginning. Okay, actually we can y-strokes is just a different data structure. It's something like an array of arrays of coordinates, right? It's an array of coordinates, but this time it's just in a y.js object. The cool thing what we can do now is we can add objects. We can add objects to y-strokes, and then they should be rendered. Oh, actually they don't get rendered. You know why? We need to observe. Let's move this one to the top. We should be able to do that. Yes. Okay. All right. Here's what we do. We have y-strokes. We listen to an event that is fired. We are not really interested in the event. Observe is called every time anything happens to this y-strokes object. Every time somebody inserts or deletes something, observe is called. And basically every time this is we insert something, we're going to re-render all these objects. And we do this by, let me indent this first, by iterating through y-strokes. And for each y-stroke, we render it. And we do this every time something happens. And since we do this multiple times in a session, we also need to remove all the existing SVG objects. All right. How do we do this? Do we have SVG already here? Let's move this to the top. All right, we have an SVG object. Now we want to remove all the existing elements that we have. SVG dot. How do you remove child elements efficiently? I think you do it like this. SVG dot first child. SVG dot delete. No, remove child. SVG dot first child. Right? You remove the first element while there is a child. You can also do maybe SVG. I think it's the first. It's the same. Okay, we remove all existing things that we already draw through, and then we render everything that we have in this Y array again by transforming each coordinate to a path, then rendering this as a SVG path. I'm sorry, did this make this more clear? Because your question was about asynchronous.
Yeah, it makes a lot more sense. It makes a lot.
Okay. So y.js objects are not asynchronous. You don't access a database or something. This is always a local data structure that is then synchronized with other peers. So while changes from remote peers come in, observe is going to be fired. And while you're performing local changes like this one, we modify y-strokes here. After this one is fired, basically, okay, console.log. This is called first. Basically, first we arrive here, then we add an element, and while this is fired, here we render every time something is pushed, observe is called. So observe is called, and synchronously, this is called synchronously, and we directly re-render all the elements. Basically, I wanted to show the workflow here. Second and third. I just wanted to show you that the event system fires synchronously, not asynchronously. Observe is called. So first, second, third should be called. And now let's run this. First, second, third, as we did before. SVG path is not defined. Why not? That's okay. We don't need this anymore. Okay. All right. Now we can do something. We can try this again. All right. Let's try this again. We have Y array, I think. No, Y strokes. How did we call it again? Oh, we don't have it on the window yet. Y strokes. That's Y strokes. All right. My computer is freezing, by the way. This is why I stopped typing. It's always a problem with Zoom. Okay, Y strokes. Now I have this. This is the exact reason why I wanted window variables, because now this is really annoying. I can't type. Okay. To array. Now we can add elements to Y strokes, and maybe they get added, rendered. Array of 0, 0, 0, 1,000, 1,000. Again, 1,000, and pressure point is 0.5. Y stroke to array is not a function. Okay, so I expected that after we added. Okay, that makes sense. We add a array. We need to add a Y array. My fault. We added new stroke. New stroke gets a few new coordinates like this. Push. And then we add the new stroke to the list of strokes that we already have. Y strokes.push. Again, it's an array. New stroke. Still, it doesn't exist. And that makes sense because we already added an element. So if you look at this, we already made we already have a bug. We added 2 elements that should be Y arrays. And now we get an error message because this is not the expected behavior. This is something that you need to care about in your applications. You can use type declaration like typings, like I do here. Like this. This is a valid type. This is the TypeScript definition that you can use. Not this one. Here you need to add numbers, but you can define that a Y array only may contain Y arrays, and then you get type bugs basically from TypeScript if you use TypeScript. Highly recommend you do that. So we can just delete the 2 elements that we added. Dot delete from 1, 2 elements. Cool. Yes, it does render something, but I don't think it's right. It's all the way up here again, if you see that. Well, it's better than nothing. I still have no idea why we can't add coordinates like this. You see that? Here, we have now the second element rendered just because we added a new element. But maybe I misunderstand how this works.
Recording in progress.
Somebody new joined. Welcome. All right.
Hi, Stephen.
Oh, Stephen joined as well?
Yes.
Oh, really? Stephen,
Yes.
Stephen, can you please help us?
Yeah,
We're
of course. Of course.
completely lost without you. So, all right, get this. Okay. When I add an element to a stroke, so you probably know your own example better than I do, but basically I created a stroke myself using an application. so this is something that I got out of your React application, then copy pasted it here just so I can render it. This is something.
Okay.
All right, and then we have some additional stuff built around this. Then we call this function that you defined, add it to an Svg path, and add it to the Svg, if that makes sense.
Yes, that looks right.
Okay. So that works. But now I want to do something like this. I want to add an array like this, starting from 0, 0, draw to 1,000, 1,000. Why doesn't that work?
Probably because it's really optimized for the type of lines that you get when you're drawing. And so sometimes it trims points, or it interpolates points, or it checks to see whether certain points should exist. Basically, it's probably reducing some noise or getting rid of some of the noise, and that's getting caught with that. I should ask, is this on like the most recent version, which probably was published like today? It'll probably have a little bit of difference.
I'm using a CDN, which should point to your latest version that you published.
Okay, what you might consider. So, do you just want to make a line from 0 to 1,000?
I just wanted to make an example, but I just need something to work. Could it be that I just can't draw straight lines? Do I need to do?
No, you could do just maybe if you put like points in between, and
okay,
probably get something else. But hold on a second. New stroke to push. Okay.
And now I'm going to walk you quickly through what we did here, but just want to try this out. Y strokes push. So this is now rendered. Still, this element is rendered as a point.
Yeah. Let's see.
All right, we can maybe start from here. I'm going to comment this out.
So if you like, let's see. I have like a couple of like helpers that I've written that sort of take two numbers and interpolate 10 numbers between them, or 10 points between them. That's probably the easiest way of doing kind of like lines like that. Because it does, it is expecting to get.
I mean, but this worked before, and now I think your comment that I need to make more points, that makes a lot of sense. So I'm trying to draw maybe something fairly, something with more shape.
Why don't you just grab part of that shape that is defined above? Like, why don't you grab like 10 points off of there?
Oh, that makes sense. Now it just did this. I don't know if that works. It worked. Guys, so I want to mention here, so we had this problem for quite a while. I was so confused why I didn't draw something. And the bug, the issue was that we can't do this. This only draws a point, but we need to add 3 coordinates. Oh, I was going crazy. Like, we tried a lot of different stuff. All right, now I'm happy. My world is healed. Thank you for this. Everything works correctly. This is really good.
I'll add that to the list. Things to do. Fix.
All right. Let me quickly walk you through what we did till now. So because it would be awesome to get your opinion. And by the way, everyone, Steve, he's the author of this awesome drawing library, perfect-freehand. And he also, and this was the reason I wanted to do this live coding session, he also has a really cool drawing application that is much more powerful and really beautiful. I forgot the name though. What was it called?
It's TL Draw, so TL and then DRAW.
Yeah, you guys should check it out and leave a star maybe on that project. It's really cool. Does it use perfect freehand, or is it something completely different? Okay.
Yeah, extensively, including for things like rectangles and ellipses, which is why I am kind of familiar with how to like simulate all the points in between 2 points rather than just the the start and end.
Oh, I never realized that. So when you're making rectangles, you're like jamming in extra points to make perfect freehand behave.
Yeah, and since I know how the pressure is going to be calculated, I'm the easing it. There's an easing curve of where those points are applied that sort of anticipates the pressure that's going to be simulated from those points.
Got it.
It's kind of weird. It's fun. But yeah,
that makes sense. Yeah, so going back to this demo, what we did till now was we created a YJS document. So first of all, we tried to make something work, and the only thing that worked was to use this shape that I had created before and draw this. And then we had the shape. All right, first we add this shape to a YJS document, and how this works is basically we define an array that we name strokes on the YJS document on a variable y strokes. And this looks like this. It's an array of arrays of coordinates, basically. Then we can do something like this, like we do here. We have a few coordinates. We create a new stroke by defining a new y array. We push these coordinates to this new stroke. And by the way, this array will then output something like, if you do new stroke, this will be basically equal to coordinates. The push syntax is a bit weird in YJS because we always push many elements, not just one. So while in JavaScript, you would do like 1, 2, in YJS, you do something like push an array of objects. This pushes 1 and then pushes 2, basically. This is something that a lot of people often get confused with. So new stroke is basically equivalent to these coordinates that we want to draw then. So we add the new stroke object to the YJS document by adding it to y strokes, which is our collection of strokes that we have on the document.
Yep.
And every time we add something, we fire an event handler. And I showed this here using console arguments. Then the observe handler is called synchronously here, then second is called. And basically what it does is remove all elements from SVG and then iterate over all the strokes that we have and basically render them as you usually do, right? So we create a stroke object here. I should probably put this somewhere else. What did I just do? I should probably put this function on the outside somewhere. Okay. We create a SVG path and add an attribute and add it to the SVGs again. So first remove all existing elements and then redraw everything. We will now optimize this a bit, but first we want to actually draw something. Does this make sense to you? Any questions?
No, that's fine. Obviously, you mentioned you haven't optimized it, but you're redrawing the strokes that have not changed along with the ones that you have changed.
Yeah.
And that'll probably be something that you want to address.
Absolutely. Good point there. Getting to it slowly, but
But yeah, that makes sense. That makes sense.
Cool. So I guess the next thing that we want to do is to actually enable drawing. And this is fairly easy. You can copy paste this from Steve's demo. Well, only if you use React. Let's get to this. Basically, we had an event handler on the SVG object. What is it? On a click. Where? We can actually go to perfect freehand, go to the example. There's an example application. Yeah, I don't know all events out of the top of my head, but it's basically pointed down, right? Yeah. In React, you do it like this, right? You register function like this, but we're going to use, the style that we had in the 80s, you know, pure event listeners. Actually, very modern. We use add event listener now on, again, what was it? Pointer down. It was the pointer down event. We are interested in, yeah, thanks.
This is more of a vanilla JavaScript example if you want to get those event handlers from that one.
All right. Somebody posted a link. Yeah, on pointer down. So we have a point. Then we have a current path that is probably defined here. We add some properties, and yeah, the path is basically SVG object. But yeah, this is basically what we want to do. Yeah, and pointer move. How do you have your pointer up? I dislike pointer up. I'm going to get to pointer up, but what is? Oh, this is my private browser. Okay, but yeah, this is basically what we are going to do. Just using event handler. Thanks for sharing that, though. So we define something like current stroke, and this is a Y object. But so this is either a Y array of coordinates, basically. Let's just, you know, assume we have a shorthand for this, or it's null. Okay, and when we click pointer down, what we do is basically we define current stroke as a new Y array. Then we add the first position to the current stroke. Push, array of arrays. And first is event.x, second is event.y. And we can do that only because we are full screen. Otherwise, we would have to do some transformations. But we have event.pressure, right? Yeah, we should have that. Okay, and then we add it to the Y strokes list. Y strokes dot push current stroke. All right, so what we do is we define a new stroke, add the first coordinates to it, and then add it to the collection of strokes. And since we re-render everything every time anything changes in Y strokes, we should, yeah, this should work. Yeah. But first, we also need to define what happens while we are moving. We can do it like, I'm going to copy paste this code here. All right. We know that current stroke is defined because, you know, pointer down was called. Then we can just push actually the next coordinates that we have. This is easy. And because we redraw everything every time anything changes, you know, we just redraw everything with the new coordinates that we have. Now I want to do like, what happens if we are actually not, clicking anything. I think the correct thing that we should do is do like event.pointer pressed or something. Only call, you know, if this is not pressed, we should just undefined current stroke and then do something new. But we couldn't do it also like this. Pressure is 0. Then we just return. So in this case, nothing is pressed. I forgot there's something on the event handler that basically says only if a button is clicked, which is compatible.
If event.button, it's in that other example, but event.button is 1 would be if it's clicked, like left click.
Event.button is 1.
Yeah, let me make sure of that.
All right, better do.
Oh, you know, yeah. The way that I
could be-
normally do this is with pointer capture rather than.
Oh, buttons.
Oh yeah. There it
Basically,
is.
this is what I wanted to do. All right. Yeah, only if any button is clicked, I guess this is, I'm not sure. Yeah, I guess. In this case, we return. And we don't add to the current stroke, but first we also want to maybe undefine current stroke. Not sure. Feels right to me. I'm not sure if we need to do it. All right. Cool. I just noticed that I said every time anything changes, we redraw everything, but that is not true. We only do that when we add a new coordinate. I will show you here. All right, we have a line. You know, E is not defined. Yeah, copy pasting code. Copy pasting code. It's event.
Line 17 needs changing as well. It wants to be on point and move.
There you go.
Yeah, thank you.
Really?
All right, let's reload this. All right. You see, we only redraw everything when we start drawing. And this is because we only redraw when an element is added to the y-strokes object. This is because this here, this redraw function only is fired when an element is added or when something changes with y-strokes. But in this case, one of the child elements changes, not y-strokes, but the child element that represents the stroke changes. There's a quick hack for this. Observe deep fires every time anything changes. This is what we want. Now, woo, we can draw. All right. Are you convinced?
Nice.
It works. All right. All right. Let's clean up the code a bit. Right. Okay. Let's remove these this tag here. We don't need the initial coordinates anymore. Any questions in the meantime? All right. Damn, I'm happy this works. New stroke is not defined. Of course not. And we also don't need to log this anymore. All right, yes. Still draws. So you see this is a bit laggy now. And this is mainly because my computer is currently overheating from Zoom, because Zoom is apparently really expensive to run on my $2,000 machine. But it works. What do you want to do next? Make it more performant or make it collaborative?
Make it more performant.
All right, you want to make it more performant and then make it collaborative?
Yeah.
Yes.
All right, that's the spirit. Okay, so making it collaborative is like connecting it to other peers. We can do that later as kind of the mind blooper that we're going to do later. Basically, because everything is in a YJS document and because we use YJS or the YDoc as a source of truth, everything should be collaborative by default, because once we connect to other peers, because it's the data source of truth is the YJS document with automatic conflict resolution. Okay, let's make it more performant though. Okay, so let's recap a bit what we are doing. So this is a bit more clear. We can ignore this one. Can I? Yes, because this is boilerplate. This function here is really important. This is where we have a lot of performance loss because we redraw everything every time something changes. This is too much. Basically, we start listening to events, redraw everything anytime anything changes, and then we start listening to the screen where we maybe can start drawing. Then we add a stroke to the Y strokes collection, and basically every time we add a point to it, we also need to redraw everything. And we can optimize this. All right, how do we do this? I would start like this. First of all, never use observe deep. It's rarely a good idea. Just use observe because you want to fire it when a new stroke is added to the object. So now we only have one event here. Then remove this code because, hey, we don't want to remove all the children all the time. Instead, you can use the changes that happened. For example, you can listen to all the elements that were added, all the strokes that were added in this iteration. We can do it like this: event changes, edit, I think, yeah, pretty sure. So for each added item, and now we are going to be a bit YJS specific. An item represents a collection of things that were added to a YJS document. This is something that you can safely use, and this is we're going to get later to the representation technique of YJS, maybe very briefly, but basically a single item can contain many elements, or it can just contain one element. In this case, we know that the added objects, the added items, only contain Y array objects. So we could do something like this: item.content.type. Because we know it's a shared type, it's not a JSON structure or something else. It's not a timestamp or binary structure that we could also add to YJS. We know it's a type. However, the idiomatic way to do this is to call item content.get content and then iterate over the content, because potentially there could be a lot of content in there. It could be many types. In this case, it's going to be a Y stroke. We know that a new Y stroke was added, or several Y strokes in a single iteration. So instead of iterating over all the Y strokes, we just iterate over the strokes that were added. All right, and like this. And this we don't need to do anymore. Now we iterate over all the added Y strokes and render them. There's kind of a problem with this because we currently don't re-render when the path was changed. We can do, so we have the Y stroke here. We create a stroke object. We create a SVG path. We define the path on the SVG and add it here. Let's leave it intact for now. After we did all of this, we call Y stroke and observe. Anytime anything changes here. So while we are drawing, we are pushing new coordinates to this stroke, right, with pressure points. And anytime somebody adds something, we can now do this. We can use the existing SVG path. Actually, we can do, is it just copy paste? I don't think it is. We also need to get the stroke here. Okay. Because this is not very, all right, this is not very pretty because we defined stroke here. So let's do it like this. We know that this code works. Just don't use variables. And then we don't have to define names for variables. I think that's a hack. So anytime anything changes, we just set the property to the current, polygon that perfect-freehand defines. And this should be much more performant because we are only redrawing the path of that was actually changed, not all the paths. We can try that out. Maybe it works. I would be so surprised if there's not a single bug in there. I would be so happy. No way. No way. All right. All right.
Good work.
I can't believe it. This didn't just happen, right? There's not a single bug there. What? Cool. All right. This is cool. Now we can draw infinitely. I guess in your application, if you want to develop like something like this, you also want to listen to remove events, and this is you can also do it like this. You can listen to the removed items, or it's called like event changes deleted, and then you remove the specific paths that you don't want to render anymore. Another thing that you can do is put this on debounce if this is a remote stroke, or use any other performance technique, because I'm not sure how expensive it is to calculate the polygon every time anything changes. What do you think, Steve?
It's not so bad, honestly. Like as long as you're not doing like, I mean, you can run up to a couple hundred strokes at the same time before you really notice. That's especially if, it's fine. I tend to try and avoid if I can. Doing like, especially while you're drawing, you only want to be rendering the thing that you're drawing.
Yeah.
But yeah, that wouldn't be the bottleneck.
Yeah. Yeah, but I guess this is, do you see any other performance problems with this approach?
So let me think. So you're saying each time a stroke is created, you create the element and you set its path. And then for that stroke, you observe changes to the stroke to get a new, run it through perfect freehand again, get the new points, and then get the new Svg path. That's about as good as you can do, really. All
right, perfect. Cool. We can even confirm
one
this.
Question.
Yeah, please.
More towards Stephen, I think. You mentioned on Twitter that you tried an approach where you draw the currently drawing line through the presence API or awareness API of YJS or LiveBlocks. I don't know.
Yeah, that's something that I did.
What was the motivation to do this?
Greater speed.
Did you get this, Kevin?
Yeah,
I don't know how to.
I didn't read it, but Francois was talking to me about it. I'm sorry, I don't follow Twitter that well.
You should start. It's awesome.
Sorry, what was the question? You guys were talking about why replit? What were you saying?
So the question, I guess, and what I got from this discussion with Francois was that Steve started using awareness API to draw real-time updates instead of pushing elements to a Y array to get greatest speed. Is that correct?
Yeah, what I was pointing out was just, I thought it was funny because me and you were debating about the different patterns that Steve had done. I think, Steve, you had posted an experiment with LiveBlocks where you were using the awareness API as the method for sort of previewing the in-progress stroke. I talked to Kevin, and it sounded like there's just a pattern that would work with YJS that's like super efficient that doesn't require that. That's the only context, like, I guess, that I said.
Yeah, that makes sense, because in a lot of different CRDTs, adding new elements is fairly expensive. It really is. And maybe I can show you this right now.
Well, I have a quick question, actually, Steve. You just did that because you could, right? Or did they recommend you try that approach, the LiveBlocks guys?
I think he's maybe currently occupied.
All right.
I hear his kids in the background, and I think it's his
sorry,
kid time.
You shouldn't hear my kids, but you do, don't you?
I was asking, did you experiment with using live blocks' awareness API or presence API, I forget what they call it, for the in progress stroking in your experiment. Why did you do that approach? Just for fun, or did the live blocks guys sort of recommend it? Guess it's not clear. I'm addressing Steve. Anyway, keep going, Kevin.
All right.
Hold on a second. Sorry. Let me answer that question. The idea was to not store just the position, but all of the last 10 positions or whatever like that since the last time the server updated. The idea is to have the packet include kind of like the recent history so that I could then on the client replay that history so that I didn't have to require the server to be updating at 60 frames per second. I could just store the last 10 things that have changed, and then it would only have to update 6 times a second. So I was like packing all that data into the presence API because it wasn't data that needed to be committed to the, like it didn't need to be synced to all the peers. It wasn't going to be overridden by anyone. That was the idea. And
right.
Yeah.
Makes sense.
Yeah, I guess adding elements to a shared structure is fairly expensive, right? Do you need to overwrite everything every time something changes? All right.
You mean for their awareness API?
Yeah, for their, I mean, there are differences, right?
Yeah, I mean, I don't know if it matters if the pattern you showed me, it just like show that.
Yeah,
I think the one weird part is just the whole like, you know, adding noise to the document and also the undo redo. And I guess someone could fuck with your data structure technically, but that's kind of like up to your app to not let someone like delete the stroke here in the middle of syncing. But
that's also technically completely fine. You can delete a stroke while syncing. Wanted to go through that later.
Okay.
So it's all about data representation, and a few things that we discussed, Francois, last week was how can you make certain things more efficient? And there are some things that are really efficient in YJS and some things that add a lot of overhead, because usually you have to, you know, modify a lot of the document, and this is fairly expensive. For example, overwriting the complete path every time anything changes, this would be expensive. But just adding a single coordinate to a path that is, you know, basically free. There's also the size of the document that you need to consider. And other CRDTs, and this is maybe not an issue with live blocks, because it's not a CRDT as far as I understand, but if you need to track history, each element that you ever created needs to be retained in memory. And adding like millions of objects while drawing, this could be super inefficient, super expensive, because the amount of clocks that you need to generate, the amount of events that modify the YJS document creates a huge history potentially. But if you do it right, you can make it fairly performant. Just to give you a quick example, you know, we have a YDoc here. Do we? Why don't we have a YDoc? We don't. All right. Window.YDoc is a YDoc. All right, just so we can do some live coding here. All right. So we have a YDoc. We can get maybe an array object first. Let's give it a different name. Let's call it here YTest. And YTest, when we insert something, let's say we insert 1, and then we insert position, then we insert 2 at the first position again, and then we insert 3 at the first position. The internal representation is, let's say, fairly inefficient. It is still very efficient, but you know, this is just as we would expect to array 3, 2, 1. But internally, what we have is start can I represent this? We create 3 objects, basically. We create one object with a lot of metadata. Then we create another object with a lot of metadata. By the way, here, the first object has content, and it has a 3. And then we have write with the first content, which is 2. And then we have another write with the first content, which is 1. You know, this is the metadata that you create and that you need to retain in memory. And because of the some optimizations that you can do, this is this is represented very efficiently in all JavaScript engines. Creating 3 objects, creating 1 million objects, creating 10 million objects, that's not a problem. But while you're drawing, you might, you know, this might be some overhead that you don't have to have. So YJS comes from mainly optimized for text editing, where you write from left to right. So I wanted to make that very efficient. Let's create a new YDoc. Let's call it D2. YTest again is empty. Now we can insert content, but when we insert from left to right, we basically don't create any metadata overhead at all. So it's basically, yeah, it's pretty much free. YTest insert insert 0, 1, 2, 3. Or we can insert them individually, maybe 2, 3 at position 1. So now we wrote from left to right. So we should have YTest to array 1, 2, 3. But the internal representation is very efficient. Start, because it's just a single element that we need to create. I'm not even sure if this is interesting to you, but it is fairly the point why this is efficient and why it is efficient to create collaborative drawing applications with YJS, because these 3 operations didn't create any other object. It's just one object calling, having 3 elements. So pushing objects is basically free, which is the point why drawing is efficient and why this can be efficiently synchronized with other peers. Yeah, I hope this made sense a bit.
Yeah, that makes sense.
Okay, cool. So you don't need to.
I mean, this one's easy to follow once you write the code for it, right? Specifically, you should be storing the pairs in a single array instead of, like, I don't know, an array of smart objects in an array.
Yeah. So what I see a lot of people doing something similar. They want to make everything collaborative. So what they do is they create a Y array. Let me draw this here. They create something like a Y array of Y.map, where each map can be, where each map is then, you know, Y map. They do Y map set X, you know, coordinates, and Y map dot set Y and coordinate. So the problem is, you need to create like three types of metadata every time you add a coordinate to it. This is just an example, but what you should try to do is, for every operation that is created, it should be either overwriting something in a Y map, because overwriting is always pretty much free, but you shouldn't overwrite different properties while you are drawing, like setting X and then Y, because we can't compress this data.
Wait, what? Just out of curiosity, why is the overriding relatively free? Because you just have to kind of keep last one wins, or what's the deal there?
So if you do like pos XY, right? If you do this instead, right? You can always overwrite pos without a problem. This should be like position. Doing this, like, you can do this 1 million times, and the metadata overhead is none. Like, it's just a single item, basically. But as soon as you iterate and do something like, I think this is much more clear, pos Y and pos X. As soon as you set these coordinates individually, the metadata overhead is fairly significant, especially only when drawing. right? Because when we are drawing, we create potentially thousands of events per second. So we iterate through this, and this is super inefficient because we can't merge these operations together, and we need to create different metadata objects basically for each of those entries every time we do something. So I recommend to bundle as much information as possible together. That makes sense. Like a position should only be position, then XY or something, right? And a stroke should be a single Y array where you push elements. And if all the actions that you perform is just a single attribute that you change or a single thing that you push to a Y array, you're golden. You can do something like this. And I want to show you how well this compresses. I'm going to create a really long line here, right? So this has a lot of points. All right.
Look at that freehand go.
It's so efficient. I mean, no, seriously, this looks much worse than it did when I didn't have Zoom on. You see it's kind of lagging, but the reason for this is because I have Zoom and Zoom kills my computer.
Yeah, I got you.
I'm
sorry, go on.
Just quickly want to show you how this compresses. We have Y strokes to JSON. So if we would use JSON encoding, we would use like 12 kilobytes of information. Well, yeah, 12,000 characters. If you use YJS encoding, we encode this document using YJS string encode state as update v2 on YDoc. It only it has fewer elements at least. And there's one performance optimization that you can do. Doubles are not well compressed. I mean, they are compressed, but you know, this is still something that we write into 32-bit, I think. If you use, for the pressure points, if you use an integer from 0 to 100, you would get compression rates of, you probably only use 5 kilobytes.
That's interesting.
Yeah. So
related to that, you're working on like a Rust implementation, or I thought you were.
Yeah, of course. There's a Rust implementation of YJS that we are porting to WASM and Python, and we already have a CFFI, making great progress. But if you want to know about that, jump on the next community call. I think we should focus more on the code now.
All right.
But thanks for asking. I'm so happy to talk about this stuff usually, but we are getting, I wanted to finish this in less than 2.5 hours or something.
Kevin, to just to demonstrate what you were talking about before about maybe updating multiple properties in a more efficient way, like, would you want to throw in like a color property to like the strokes just to see, you know, maybe something that changes every time you do this? I'm not sure what a good arbitrary value would be, but something where a stroke doesn't have just the array, but some other property in addition to that.
All right. Yeah, we can do that. There was something I wanted to do anyway. I wanted to have a few colors, a few user colors, because I wanted to do an awareness API later. So maybe we can just quickly. There's like on my website, I use a few colors that I really like. These are just some random user colors that we can use. Okay. Colors. Let's first, well, actually we can name it user colors, doesn't matter. All right, we can add properties to the stroke. Now the stroke object becomes a bit more complex because it's not just a Y array anymore. It's not just a Y stroke. We can now define a Y stroke maybe as, you know, if this was a JSON object, we could form it like this. It's like maybe has a path which is a Y array, and of coordinates, you know, and maybe it has a color. Yeah, and this can be a string, right? A string that we just fill in, and then we fill this stroke with the color. So Y stroke, we can't do to array anymore. We need, now we are going from top to bottom and check whether we need to change something. This is all not YJS related. This one is, so here. Okay, we have Y stroke dot get path. We call it paths to array. So path is a Y array that we define on Y stroke, because Y stroke is now a Y map. A Y map is a key value store, and on this key value store we can also store a path. Again, on the Y stroke, do we do anything else here? We observe changes on the path. So we want to do get path observe. That should work. Yes. And we can do Y stroke dot observe. So this is the Y map that we are now observing. And anytime anything changes, we now actually we can do it like this: event dot keys changed has color. In this case, we're going to do Svg Path dot set attribute. Is it fill?
Mm-hmm.
Okay. In this case, we use Y stroke dot get path, get color. All right, we set color, and we also need to define the initial color. We do it here. Set attribute. Okay, before we add it to the SVG. Copy pasting doesn't work anymore. Oh, now it works. Fill with this. Cool. This is the initial color that we have. Next, pointer down, we need to change.
5.
What did you say?
End of line 55.
Yeah.
Y stroke to array doesn't look right.
Y stroke, get stroke. Yes, thank you. Get path. Perfect. Get color. Set. I guess we're going to find this issue again in the debugger later, if there are any more issues like this. Okay, and this now is a Y map. I don't even want to define the whole typing here anymore. Okay. Current stroke is a Y map. And we initialize this Y map using a color. Current stroke dot set color. And now we can use a random color of colors, the user colors. We're going to name it colors, and then we get color. We're just going to call this colors, and we didn't define one of. I think it should be standard. So one of takes an array, any kind of array, and returns a random entry from that array. And we do it like this. Yeah. Math.random times r.length, and then we get the floor. Math.floor. Okay, cool. This just takes a random entry, I think. What gives you something else? We will find out later.
You written it as const. The
Again?
no, it won't be two consts.
Oh, thank you. Thank you a lot. Perfect.
Very constant. Very constant.
Yeah, I just want to be sure. Okay, so we get one of the colors, set this as the color, and then we create a path, const current. We're just gonna name current path. It's a new y.array. Yes, and then on this current path, we add the initial coordinates, and then we do current stroke set path to the current path. So at this point, we know that a path has a stroke. We are sure that a stroke has two properties: path, which is a Y array, because we defined Y array here, and it has a property color, which is a string. And then we add current stroke to the list of strokes. And this sounds right, but here we need to do get path. And then we push entries. And I'm very sure that there are no bugs. There's no way. What? Huh?
Congratulations.
There's no way that I did that, right? I'm really proud of myself. This rarely happens. Cool. So we define a random color on this path. Of course, we can have some kind of menu that defines the current color or something, but I don't think we need to do this right now. Oh, this is much beautiful, much more. All right, what else? I could show you how to remove elements, or I can make it collaborative. What do you want to see?
Sorry, can I make another request here? This is going to look terrible. I think the thing that I'm looking for is on line 86, right? Where you're updating current stroke.
Yeah.
If you also wanted to do something awful, like also assign it a new random color, which would look terrible, but let's say you wanted to make both of those changes at the same time to the map. Is there a way to sort of batch those changes, or to do them both at the same time in an efficient way?
You want to do it per stroke, or like literally per like
as you're moving the mouse? Let's say you wanted to. I'm only doing this because I'm curious about making those type of bulk changes, but I think in this case the only way to do that is to also make the color change every time you move the mouse. But if you wanted to change both of those properties at the same time, how would you do that?
I would add a new property here, color. Basically, if you want to do that. So then you can draw, because you start with blue, and then eventually you decide I want to be yellow, and then you want to be red or something. So you just add a new property to this, and then this would be your job. Perfect freehand needs to understand colors, so you can make rainbows, right?
I guess you could pull that. I mean, it won't delete that data. It'll still be there. So you could probably pull that out of the
I mean, something
line, whatever, wherever you're updating the SVG.
Yeah, you can just pull that out, of course. Yeah, you can
Mhm.
just pull that out. And I think this would be kind of your job to define then a polygon that can render these different colors while you're drawing, right? But the data representation would be this. YJS is for data representation. And at the moment, right, without this property, you can only have one color per stroke. But if you want to add more, so for example, you can add color, and you can maybe add a speed property, which is like the speed in which you move the cursor or the time since the last entry. because I'm sure if you have this information, you can draw better curves. This would be another option, but even overall, I would recommend this approach here.
Okay, so just kind of pack all the changes into the same data structure if you can.
Yeah.
Yeah.
But in general, if there are some operations that you want to bundle, where you want to, for example, when you want to add a path and at the same time remove another path or something, maybe this is something that would be interesting. I don't know, if y strokes dot length is bigger than 2, we remove the first entry y strokes. Oh, this doesn't actually work because we don't have remove functionality. But what you can do basically, if you want to do 2 things in one transaction, you can do ydoc.transact.
Here we go.
Yeah. And then you basically perform your stuff, like pushing, and you can do multiple things all at the same time. And basically the cool thing here is all event handlers are actually always fired synchronously. Like usually you would fire here the observe event and the update event. And when you do a lot of actions, like maybe 10 actions or something, you don't want to fire 10 times the observe event and 10 times the update event. So instead, you're going to wrap this into a transaction, and then you fire the observe and update event. And there are actually quite a lot of different events, like before transaction, after transaction, that allow you to, do some custom stuff, like listen to the state that you had before before you apply a change, and then you can compare that to the state that you had after the change. A lot of different things that you can do with the observers, but all of this stuff, the observers are always called after the transaction. So bundle as much together as possible. Yeah.
Cool. That's what I came here for. I'm like, there's got to be something in this library.
Yeah,
that's great. That's wonderful. All right, cool.
Cool. And yeah, the interesting thing is the event system is built in a way that even when you call this, like adding 3 different strokes, the event system is going to be something like, maybe the delta is more interesting because it's going to be delta. Delta is a representation for changes on a Y array, and the delta is going to be on position 0. We do insert. Wait, it's like this. I'm sorry. So it's insert, and then stroke 1, stroke 2, stroke 3. So you only get a single event, although you just push 3 individual changes. So everything is bundled into very compact events that you can efficiently represent in your application. This is fairly important for writing editor bindings, because you don't want to apply each event individually. This would be quite some overhead in a lot of cases. All right, but we don't do transactions here because I don't think there's a need for it right now. I can't come up with something. Any other questions? All right. Yeah.
No, good. No,
okay.
Sorry. Go for it.
All right, here I go again. What do you want to see next? Deleting objects or collaborative, making it collaborative? Somebody needs to say something. Just scream.
Collaborative.
Yes. Yeah. All right. Thank you. All right. I mean, this is always the coolest part, right? And now we have pretty colors, so this is going to be much more amazing than before. What we need to do is we need to import a provider that shares a YJS document with other peers. There are many different providers. Just looking at the documentation, we have a list of connection providers. This is basically how you share your data with other peers. You can share it through the DAT network, WebRTC, WebSocket. I know that there's a Firebase provider now. This is really cool. And there are some companies that want to build a provider for their existing product to make it collaborative through their pub subsystem. So this is going to come. So you just need to, decide which provider you want to use. And for this demo, I'm going to use WebRTC because there is no setup at all. Using WebSocket is also fairly easy. You need to set up a server that you run on, some machine. And then you can connect to that server to share data, and the server then can, save it to a database, save it, do some custom stuff with it, trigger events in your custom application. But for demo applications, let's use WebRTC because WebRTC doesn't need a server. It only needs a signaling server, which is basically used to connect different peers to each other. Basically do import WebRTC provider. All right, thanks for joining, Francois. I'm going to put this this recording online. You can check it later. Exactly. All right. WebRTC. All right, we are going to use version 10 of WebRTC. I think that's the current version. Let's quickly check. We have tags, yeah, version 10. So it's version 10. And then we basically define the provider is new WebRTC provider of, first we give it a room name. Let's call it our song drawing. And we connect it to a YJS document. And optionally, you can define your own signaling servers. There's like signaling, this is an option, and then you can define some servers. But I have a bunch of signaling servers already set up to make sure that, we can have a lot of users using WebRTC without any setup. So this is literally everything you need to do to make something collaborative, at least share content. Now we can run it. All right, this is the initial content. All right, you see, I got the content from the other peer. I'm going to put this on the side. And while I'm drawing, everyone can see, right? What? How did you do that? What? Somebody else is joining the session. Who is that? I didn't share the link yet. I just shared it on the chat. Feel free to maybe join this application so you can try it out. All right. And so no more drawing happening. Oh, there's another user. All right. Yeah, so this is fairly impressive. Oh, somebody has a really big screen, right? We need to zoom out to see everything. I'm currently on low resolution, so this makes a nice recording. Yeah, thanks. Okay. You can continue drawing on this one. Is there any question about the provider? So something we can do is, yeah.
Oh, sorry. Yeah, this is Raja. One question, quick question to you, Kevin. Kevin, here you have not mentioned any signaling server, right? So is it possible, like even on our own, can we set up our own signaling server, or does that required actually? Or suppose if application is very big scalable, do we have to go with our own signaling server, or still we can go ahead with like what all you have set up, like a bunch of signaling server, as you say, set up, right? So we can use that itself. What is your point here, Kevin?
Yeah, you should absolutely, if you use build a production application, don't rely on my signaling servers. Use your own signaling service. It is very easy. They're included in the Y project. So here, if you go here, there's some documentation on how you can start your own server. Here's signaling. You basically start server.js, and server.js is a basic WebSocket server that has some custom features. For example, it allows you to encrypt messages, so only users with a password can join, and do some other stuff. Just run this yourself and figure out how to scale it. This is very easy.
Okay, good. So that was my question. Thank you.
Cool. All right. I was thinking that maybe we can add some awareness functionality or add functionality to remove strokes from this application.
Can I ask one question about providers?
Mm-hmm.
Is it possible to have, you said that there was a Firebase provider, like if, let's say I wanted like persistence, but I also wanted responsiveness, could I use a Firebase provider and a WebRTC provider on top of each other and that would just be fine?
Oh yeah, you can use many different providers all at the same time. Regarding the the Firebase provider, I'm not sure if that person actually wants to open source it, but I saw it and it's really cool. It's fairly easy to build as well, to build a Firebase provider. You can use different providers all at the same time. For example, WebRTC and Firebase, that would be a really good match because Firebase is fairly fast and provides persistent, and WebRTC is just really fast, so just use them all at the same time. You can also use the WebSocket provider and WebRTC at the same time. And something else you can do, and this is, I don't know, maybe cool, you could just connect to a different room as well, and then everything will be shared in 2 rooms.
Okay. And then the other question was, so with Excalibur, it would be, they have a room ID as part of the URL when you share a link. And then they also have an encryption key with the server never sees. So if I wanted to have all of my peers have, so that password, is that essentially an encryption key?
Yeah.
Okay.
So this is just for WebRTC. Is it password? Yeah, it's password. What this actually does is, so WebRTC connections are always encrypted. So when 2 peers create a connection, it is enforced that each of them creates a certificate, or basically, what is it called? A key that they use to encrypt. It's Diffie-Hellman, right? And then they each encrypt their messages and use the foreign encryption key to decrypt, right? This is what's happening. But what is not encrypted is the connection to the WebRTC provider. Well, actually, the connection is encrypted because you create a WebRTC connection like this. We actually need to reload this. It's an HTTPS WebSocket connection. Somebody added something invalid. Thank you for that. It's a HTTPS connection, but you see the messages are currently pretty plain. Everyone can basically connect to this room and say, hey, I also work on awesome drawing. But when you provide I'm just going to use a different room ID here, 33. But when you provide a password and reload, what the server then will see is encrypted data. It will only see what peers want to publish, but it's basically encrypted data. Nobody can read it except the peers that have a password. The signaling server knows who is collaborating with whom, but they are unable to intercept the connection and read content or something, because peers will only attempt to connect to people who know the password, and the server actually doesn't know any of the signaling information. which is often also private, and you don't want to share that. For example, your local address, all these information that is part of the WebRTC protocol. Yeah, so always provide a password, maybe.
Other providers, like if you were using the WebSocket provider directly, for example, would they have similar functionality where you can actually no,
so it doesn't.
You build that into whatever provider I made.
Yeah, you can create your own provider. If you are interested in encryption, you can use Serenity backend. Yes. Well, Serenity Notes, I think. Yeah. So Serenity Notes is a end-to-end encrypted note-taking application by Nick, who is awesome. This is open source. It is also something that you can subscribe to. And he made the backend as open source as well. And maybe you can modify the backend. The backend is probably the most interesting part here because it is built on the Matrix protocol, which is like a messaging protocol, which is the same protocol that Signal implements. So Nick basically uses OM framework to encrypt messages end-to-end and provide a lot of securities that other applications don't do. And it doesn't just encrypt messages, it provides forwards and backwards secrecy. Honestly, I'm not really up to date on all the terms, but this is basically as good as it gets. So check this out.
Like in my action plan, if I wanted to do a port, it would probably want to be for Excalibur, it would probably want to be like with no regressions, and currently they do have end-to-end encryption, so like that's the thing that I would just need to think about when I'm doing it. But I think that makes sense.
Yeah, if you already have end-to-end encryption, you can build on the same technology. Building a provider for YJS is fairly easy. There's a quick documentation on the website here. I probably shouldn't go through this, but it is really something that almost anyone can do. You just have to read a bit about the update format and how you can store messages in an encrypted way. And there's an entry in the discussion board about how to create a end-to-end encrypted backend using YJS, discuss.yjs.dev. Go here and search for end-to-end encryption, and you will find something.
Thank you.
Sure thing. All right. Any other questions about providers? Cool. All right. All right. There's one more thing that I want to do, and that is providing awareness information, because this is something that I think everyone should implement. Awareness is the ability to sense what other people are currently doing and getting some hints about what they're doing. For example, sharing cursor information is awareness information, but also knowing who is currently online and maybe giving them a user color and giving them some kind of identity so we know who we are working with. You know, in our current application, while we are drawing something, we don't know who is modifying what. And we can at least provide some hints of, you know, who is who and what they are doing. And all right, I'm gonna add, add some names to this so we can experiment with the awareness API and share some awareness information in the sense of we want to share cursor information, where each cursor is. We can do that. First, we create some random names. Why is this exported? We don't need to export. Let's create some names. And there's always Alice and Bob. and there's maybe Stephen and Francois. Okay, these are just some random names that we are going to assign to the people. And this is how we do it. Maybe we should move. No, it's fine. Let's leave it here. We define the provider here, right? And each provider that I work on defines an awareness instance. Let's first define it, and then I talk about what this actually is. Right, awareness is also a CRDT, the awareness CRDT, but it has much less functionality than YJS. So awareness CRDT and YJS CRDT are completely different things, but all my providers that I implement provide an awareness CRDT as well. Basically, they share the YJS document and awareness information through the same protocol. This is what this is doing. You can implement that yourself using your own API, and I recommend to use the CRDT that I implemented, but you can also implement your own thing. It doesn't really matter. It's just a way to share information about yourself with other people, and then also notice when other people go offline. There are some cool tricks in Awareness API. For example, when I register, and here's how I register, I can do awareness.set set local state field. I can publish some information about myself. For example, I can publish the information of who I am, name, and the name would be one of names. So now I have a name. I just grab a random name from this list, and I maybe also have a color. One of colors. All right, now I have a color and a name. And this is something that everyone can listen to. And at some point, I'm going to go offline, and maybe I close my application properly. Then my WebSocket provider or my Webrtc provider is going to publish a message to all the peers and notify them, hey, Kevin is currently offline. Just render them as offline from now on, and they don't have any associated information anymore. But sometimes I also close maybe my window completely using this button, or I restart my computer forcefully without unregistering properly. And then there's a timeout that each user has about every other user. And you basically notice a user hasn't sent any update in 30 seconds or in 1 minute. We're going to mark them as offline or as unreachable for the moment. These are some cool functionalities that this API provides. Then you can do awareness dot. It has an event system on change. It has an event as well. And then you can basically do console log awareness get states. And states are all the states that some user published. My local awareness state after calling this function is basically user equals, everything that we wrote here. But you can publish more information about yourself, like maybe you want to add a property like the cursor position, which would be X and Y coordinates. You can add that as well to the states object, and we're going to do that later. All right, but for now, let's just log this and then see how when this is called. Maybe give this a name, awareness change. Cool. Let's run this. One off before initialization. Oh yeah, that makes sense. Put this to the top. Okay. I'm the only user in this room. By the way, I changed the room, so you need to change it. Oh, okay, other people joined as well. So now I get notified that another user joined, and their name is Alice, and I'm currently, well, I actually don't know who I am, but there's Francois, again Francois with a different color, and Alice. Apparently I'm Francois, and then this event got called again with Alice. So we have two users now. What we want to do now is render the location of each user in their respective user color. Maybe we can do that at the bottom. No, we can do it at the top again as well. Doesn't matter. All right. And how we do this? I would say we add a circle to the SVG element at the position where that user is currently. Basically, we can re-render everything. Yeah, let's go with the re-render approach again. Don't re-render individually. You know how to do it more performantly now. Okay, what do we do? First, we get all the states. Awareness.get states. Then we iterate through them. So this is a state of a single user. And we assume that they have a position attribute that we're going to set later. Maybe we circle back and just implement the position attribute first. Pointer down doesn't matter, but every time we move the pointer, before we actually return, like this is something we do all the time, we do awareness, set local state field with a position with X and Y coordinates. Y is event.y. So we now published our position. And after this is called, immediately this event should be triggered. Awareness change. And then we can render it. So let me copy paste the code that we used for path here, because I don't remember the syntax. Here we go. But this time we make a circle. All right, and a circle. I'm not going to pretend that I know what a circle has some weird properties. So this doesn't make, why is it CX and CY? This doesn't make sense to me. All right, let's use this as a template. SVG circle dot set attribute CX is before we do this, we also need to check whether position actually exists. State.pos. If position doesn't exist, we just return. Because it could be that our current user is online, but they don't have a position yet because they are not on the canvas or something. And then we didn't set a position. So we need to check whether it exists. And when it exists, we can render the circle with pos.x and pos.y. And a radius of, I don't know, what is a good radius for this? 10. All right. So we re-render the circle every time. And while I'm moving here, I should see a circle, but I don't. I don't see a circle because I'm not adding it to the SVG element. SVG.append child SVG circle. Okay. run. Oh, okay. I guess it's pretty good. We're adding circles, but we're never deleting them. Let's do svg.query select all. And this is, don't do this, but this is just a quick hack. You can optimize this later. I don't want to make a full solution here now, but basically we can query for all the circles on the SVG element. And for each element, circle, we can call circle.remove to remove it. So we start fresh every time this is called. We re-render everything. Okay. All right, I now have a black circle following me around. Next step is probably to add the user color. Circle, let's do it like this. I want to fill this with pos.fill. Not pos. It is state.user.color. And every user should have a color, so that should work. Let's run this again. I have a random color, and currently it's yellow, and the circle is following me around. And if I restart this application here, okay. I don't want to see this one. Yep. So you see on the left screen, I now have a circle, my mouse moving over the canvas. And yeah, another person just joined, and we can now see user colors in the form of circles. This is not super pretty, and this is way too colorful right now. But yeah, we probably don't want to see our own circles, though. What we should do is, so the states are actually key value maps. A state is always associated to a client ID. All right, and basically, we can do it here. We can do it as a separate condition as well. If client ID equals awareness.client ID, in that case, we just return. Okay. Oh, it's my computer is freezing up. Please don't write too much. Oh no, I clicked on the wrong button. Cancel. Not this one. Okay. Come on. Like this. And now this only needs to start. Why doesn't it start? All right, let's duplicate this tab. Now we have two applications. All right, now it works. You see my cursor on the right window, and on the left window we share the red circle, which represents my cursor. And we can see another user over the surface as an orange bubble, basically. How you can optimize this easily now is maybe by creating a cursor object, like a better, not a circle. Circles are not that beautiful, but maybe a cursor object, and also render the name of the user who is currently going over the surface, so you get more information of who is actually who. At the moment, we only know their user color. But this I leave to you as an exercise. Do you have any questions about this? Was this maybe too fast?
No, not at all. This is perfect.
Awesome. Cool. I actually did everything that I wanted to show. Kind of surprised, only 2.5 hours. I'm really glad so many of you sticked around that long. I'm gonna leave this open to what few more open questions. If you have any just questions about anything, then I'm gonna close this. Then I'm gonna stop the recording, and you can ask some other questions that you don't want to share publicly if you want to. Are there any questions you want to ask?
I mean, they're not directly related to YJS, so we can pause the recording, I guess. So they're just general questions about like it's something that I just wanted to ask is like, in whatever you've experimented with, like, have you seen a difference with like WebRTC and WebSockets? Like, have you seen a performance difference using one or the other? Not generally related to YJS, but like what would be better in what case? And like, for example, would you use WebRTC for one case and WebSocket for the another case in the same application? I think somebody asked a similar question previously about using different providers for different things in the same application.
Yeah, the question is, yeah, okay, which providers I should use for different use cases, right? While you were talking, I noticed that I forgot one important provider that I wanted to mention. So there are different use cases for everything, right? You can build any kind of provider on any kind of PubSub server you want to do. Like, I recommend if you have an existing infrastructure, you already have a PubSub server, you already use Redis or something, build your own provider. If you have something that already communicates with your clients, you have a Socket.io application or something, use Socket.io to build your own provider. If you want to start with something existing that is maybe even optimized and that other people also use, start with WebSocket or WebRTC, depending on your use case. Most production applications want to store their data on a server and on a database to make this, very secure and scalable and reliable. In that case, use WebSocket or some other centralized protocol to store your data, because at the moment we don't have good solutions to integrate to build a peer-to-peer offline-ready applications for production companies or something. But this is something that you can experiment with, because you can fairly easily build a decentralized application using Y-dat or WebRTC, if that is something you are interested in. Yeah, but this is my recommendation. There are a few use cases for productive applications if you want to build a real product where you want to use WebRTC, because WebRTC is not very reliable, especially if you work with people from different regions. For example, the big firewall in China often prevents users to collaborate from Europe to China because there are some connection issues, just random ones. So you basically have different fragmented networks that can collaborate or talk to each other. Users that use a 3G connection over a different mobile provider can collaborate with other people from a different provider. I have no idea why that is. It is because we have weird firewalls and weird restrictions that I personally also don't understand. So maybe don't use WebRTC for production. Yeah, for anything else, build your own protocol or use WebSocket.
Fair enough. That makes a lot of sense.
Yeah.
I mean, I was just also thinking, like, maybe for data that you need to sync with the server, use WebSockets, and at least for the awareness API, use WebRTC, I guess, because that data you don't need to just sync in the server, I guess. Does that make sense?
It does make sense. Actually, it would be interesting to just share awareness information through WebRTC. And for anything that needs to be persisted, use a persistent protocol. I like that idea, and definitely you can do that, because awareness information, it doesn't matter if other people don't notice it. So that is a really good recommendation or really good idea. You can do that. Usually WebSocket is fast enough for this stuff.
All right. it's not worth the hassle of maintaining two providers. All right,
Yeah.
all right, fair enough.
And another thing is, if your provider for sharing awareness information is significantly faster than the sync provider, then the cursor information arrive much sooner than the actual entry that you do. For example, when you type the character A, your cursor information is now after the character A. But if the character A doesn't exist, the cursor won't be rendered, because we don't know where to render, because we don't know that this character already exists. So you get into weird issues.
Fair enough. Yeah, that makes a lot of sense. Oh.
Okay. Yeah. Any other questions? All right, cool. I'm going to stop the recording. Thanks for everyone joining till now.
It was great, Kevin. Good session. Thank you.
Thank you.